Now we'll do a short question. ABC PLC has the following cost, volumes, and drivers. Production and sales, 3 products X, Y, and Z, 30, 20, and 8K. Direct material cost, 25, 20, and 11. Direct labor cost is 8, 12, and 6. That's just like absorption costing, no difference. These figures can go to the cost card just like that. We had machine hours are 40, 20, and 16K. Total machine hours are 76,000. Number of production runs, total are 30. Number of deliveries and number of production orders. ABC PLC also have identified the following cost pools and their associated cost. Setup, 30 machines, 760,000, packaging 250K, and engineering 373. The total is 1.413 mil. These are our cost pools, and obviously for our question they're just 4. In reality there will be hundreds of them. So that's why you will not see much difference in question on activity-based costing and absorption costing. In the past, the company has allocated overheads to products on the basis of direct labor hours, absorption costing. The company has since investigated the use of activity-based costing and have produced the cost pools and driver information. You are required to calculate product cost using an activity-based costing system. So what we have cost pools, setup 30, 760, 250, and 373K, and number of production runs. The first one is solved for us. So if you look at this data, number of production runs total 30. Setup cost, the cost driver, setup cost is the cost pool, and what drives the cost upwards is number of production runs. The more we produce in different batches, so as the number of batches increase, the cost of setup increases. Then we have machine hours, 760,000, that's the total cost, and machine hours are 76,000. How this rate is calculated, it will make a lot more sense if we do it on Excel. So total machine hours, if you look on the data sheet, our machine hours are given here 40,000, 20,000, 16,000. So the total is 76,000. If we divide our 760,000 with the total machine hours, we get the cost per machine hours. Next one is pecking order. So these are dispatching, preparing for a dispatch, that kind of cost. The total money we spent on maybe staff and packaging material was 250,000. And if you look at the number of deliveries, we had 32. So these are the total number of activities are the drivers, and the cost per driver in this area is 250 divided by 32. So we get 7,812 pounds and 50 pence. Next one is our engineering. So the cost of engineers and the related activities, I believe that would be based on production, number of production orders. So we got number of production orders as 50, and the cost per production order would be 373 divided by 50 is 7,460. To sum it up, every time we set up, it costs us 1,000 pounds. So if a product uses more setups, that means it is made in smaller batches. It would attract more of these costs. If a product uses more machine hours, then it will attract more machine cost. If a product has more number of orders, even though it is sold in smaller quantity, but every order is smaller, so it causes more orders, it will attract more cost. And similarly, those products which requires more engineering work, maybe more number of inspections or more faults, then it would attract more cost in the engineering area. Next is our cost card for these three products. As you can see, I have transferred the slide onto my Excel now, and we have direct material and direct labor for three products. We can calculate prime cost for these products, which will be labor plus material. We copy the formula, Control C, arrow, Shift, select, Enter. So we got our prime cost. Let's give it a gray. All right, and then we have number of units, and we can calculate the cost for the total units as well, which may not be the best idea, but that's what the structure slide is giving, so I'm gonna follow it. Normally it's better to calculate the direct cost and overhead cost for one unit first, and then at the end you multiply it with the number of units, and that makes life a lot more easier. So these are my direct costs for X, Control C, and we got for Y and Z as well. Now we are going to deal with our overheads, which are the main problem in all of the cost accounting questions. So first of all, we have setups, and here we have calculated the cost of each driver on the slides you can see. So what we need to do is basically simply multiply the rate with the number of time each product has used that activity, and that is given in our sheet. So first of all, if you look at setup, the number of production runs, and that is basically setups, were 3 for X. And so 3, remember this please, 3, and each time it cost us 1,000. So equal sign 3, not 30. So 3. Then we have a setup cost for Y. We got 7 setups. The cost per setup is 1,000. So 7 times 1,000. And then for Y, the number of setups are 20. And the cost per setup is 1,000. And we get 30,000 in total. So if you total this up, you can see it's 30,000, and the total setup cost was 30,000 as well, which is given here. Okay, so the next is our machine hours. Cost per machine hour is 10. I remember that, which we calculated here. So that's per machine hours. You need to see the number of machine hours now. Machine hours. So X cost 40,000 machine hours times 10. Y cost 20,000 machine hours times 10. And Z costs 16,000 machine hours times 10. So the cost of the machining has been distributed as well. Again, I'm going to do a double check, and that gives us 760,000, and the cost of machining was 760,000. Next is our packaging. The cost per packaging is £7,812.50. And now we need to see the number of orders. And those are 9, 3, and 20. So for X, 9 into 7812.5, that is each driver cost. And that is quite a lot of money for the ordering or packaging or dispatching. Again, for Y, we have number of deliveries as 3 times 7812.5 and we get a figure of 23,437.5. And for Z, we had 20 dispatches times 7812.5, and we get 156,250. Next is our engineering. The cost per engineering hour, which we calculated, is 7,460. So let's go here. All right, so for X15 production orders into 7480 per engineering hours, then we have 10 into 7480. Is it 8 or 6? 6. So I've been doing it wrong. No problemo. We can correct it. 6. And then we have for Y, number of production runs were 25. Where am I? 25 into 7460, and I get the total cost. Let's give this a comma and remove zeros. Now it looks pretty. So the total overheads cost can be calculated by adding up all of these. Got our answers. Let's give it a grade 2. Okay, so the total cost can be calculated by adding up our overheads with our total direct costs. Same formula. We get the total cost for each product. We can calculate the total cost per product as well by simply dividing it with the units, which you already got. So that's why it's a good idea not to multiply first, because it just duplicates the work. And right at the end, you can simply multiply it with the number of units rather than you have to divide, and you can get cost per unit. So cost per unit would be divided by number of units, and we get our cost 1575. That's all for this question, guys. Thank you very much for watching this video. I hope it helped.